This is the office hours video for section 5, trigonometry. Now, the word trigonometry means the geometry of triangles. And in this office hour video, I'd like to talk about the solution to the Now You Try It exercise in section 5. And the problem says if the sine of the angle is 0.6, then what is the tangent of the angle? Now, one very straightforward way to solve this would be to use the sine equation, take the inverse sine of both sides, and figure out what the angle is, and then substitute that angle into the tangent function. But I'd like to show you another way to do that that I think might be instructive in thinking about these functions, sine, cosine, and tangent. So if you start with the Pythagorean theorem, which says the hypotenuse squared is equal to the sum of the squares of the other two sides, if you divide every term in the Pythagorean theorem by the hypotenuse squared, so I'm going to do that. The symbol for the hypotenuse is c. So I'm doing everything to each term so it doesn't change the validity of the equation. So c squared over c squared is 1. I'm going to rewrite the equation. A squared over c squared is a over c squared. And b squared over c squared is b over c squared. And then c squared over c squared is 1. So if you look at the triangle, which corresponds to this equation, the hypotenuse is c. And if I put the angle in there somewhere, I'll say the opposite side is a, and the adjacent side is b. So if you look at the equation that I just formed by dividing by the hypotenuse squared, a over c is the opposite over the hypotenuse, which is the same as the sine function, sine of theta. And if you look at b over c, b is the adjacent side, so b over c is the adjacent over the hypotenuse, and that's the same as cosine of theta. And when we have trig functions squared, we usually write them like this. We put the exponent in between the letters and the angle. That's the way it's usually written. So by starting with the Pythagorean theorem, you can end up with this, which is called the Pythagorean theorem in trigonometric form. And this can be very, very useful when going to solve problems involving trig functions. So in this problem, what would cosine be? I'm going to solve for cosine. So cosine squared would be 1 minus sine squared. And then take the square root of both sides. Cosine can be both positive and negative, so I'll include both of those possibilities. So plus or minus the square root of 1 minus sine squared. And so what that allows us to do in this problem is to figure out what the cosine of the angle would be, without ever actually figuring out what the angle is. So if I put in 0.6 for sine, uh, 0.6 squared is 0.36, and 1 minus 0.36 is 0.64, excuse me. And the square root of 64 is 8, so if you work this out, the square root of 0.64 is 0.8. So if the sine of the angle is 0.6, then the cosine of the angle is going to be plus or minus 0.8, and I just figured that out without ever using the numerical value of the angle. So it can be a big time saver in some cases. It can be also very useful when you don't know what the angle is. Now this problem is looking for tangent. So I'll use the other very useful trigonometric relationship, which is that tangent is the same as sine over cosine. And so if I put in what sine is, 0.6, and what cosine is, plus or minus 0.8, if you divide these, 6 divided by 8 is the same as 3 divided by 4, so that's 3/4. So it's plus or minus 3/4, which is 0.75. So if you look back at the Now You Try It exercise in section 5, you'll see that the correct answer is A, 0.75 or negative 0.75. So I thought I'd go through that, not just to figure out the answer for that exercise, but also to demonstrate a way for you to think about trigonometry and how the trig functions are related to each other in cases where you don't know what the angle is or you don't really care what the angle is. And this is going to happen a lot in physics, where we're going to use trig functions to describe physical quantities, and these sort of tricks will become very useful. So try playing around with that for a little while, and I hope that works out well for you.